Hi there, my name is Anton and you are on the channel Anton Coded. Today we are going to solve the second day tasks from Advent of Code. Let's start. Okay, task called 1202 program alarm. Let's check it out what we gonna do. Okay, on the way to your gravity assist around the moon, your ship computer beeps about alarm. Okay, let's go near. An in-code program is a list of integers separated by commas, like, okay. To run once, start by looking at the first integer called position. Okay, here you will find an opcode, either 1, 2 or 99. Okay, there are only 3 positions. The opcode indicates what to do. For example, 99 means that the program is finished. Okay, 91 means that you should break your loop, I think, through the int codes. Finished and should immediately halt. Countering an unknown opcode means something went wrong. Okay, opcode 1 adds together numbers read from 2 positions and stores the result in the 3rd position. Okay, the 3 integers immediately after the opcode tell you these 3 positions. Okay, it's okay. For example, if your in-code computer encounters 1, 10, 20, 30, it should read the values at positions 10 and 20, add those values, and then overwrite their value at position 30 with their sum. Okay, opcode works exactly like opcode 1, but it multiplies 2 inputs. Okay, that's great. For example, suppose you have the following. Okay. Here are some complex examples, but I think we wouldn't look for it. I think I get it. I get what we need to do. Let's get puzzle input. Okay, it's separated by comma already, and we don't need do nothing. Let's create directory. Day 2. Also add simple data. Today we are going to use modules, export default. Okay, great. And index mjs, where we can import data from data. mjs. Great. What we are going to do here? There are some parts of algorithm which will be repeated. I guess we can write some function, call it get operation, operands, I think, yes, and we just put position here and return data position +1 +2 and +3, something like that. We've got a position of an operation, yes, and we need 3 operands of it. From two of them, it's about from, where we need get some values, make some operation with it, and store at position 3. Okay. What also we need to do? I think we can write another function, solve. We put there nothing, and it should make some work. Then we just start it, and here we need some put some code of it. Okay, I think we can just make some loop for iteration through the data. For let it would be index e smaller than data length and e plus 4, because we've got for each operation we've got 4 numbers. First of them is it means operation, sum or multiply or exit from the cycle, and 3 of them is about operands. Okay, operation, it would be data I, yes, and A, B, C, it's I think we can just return also an operation. That's it, and it would be something like that. Get operands and index. That's all. Here we need some switch case through the operation. We know that operation can be 1, then we just put data C, A plus B. Break, yes. Case 2, we need multiply, data C, not A, B, data A, and data B. Data B, yes. We need just multiply, it's break, and case 99, we need break our loop, but we can't break a loop here. To break it, we need add some label for it. I think we can iterator, call it iterate, and we just break iterate. Yes, and we need read console, let it be console, And I think we need data. Let's read about it. Wow. Yes, what value is left at position 0? But before running the program, replace position 1 with the value 12 and replace position 2 with value 2. Okay, I'll copy it to the editor. Okay, what does it mean? Replace position 1. Okay, it would be something like that. Data 1, 12. Data 2, 2. Yes? I think that's all the code we need to solve it. Let's start it. To start it, we need go to the directory. It's 11. Simple, yes. And we need just start our index.mjs file, but with a flag. Experimental modules and the index.mjs. Yes, that's all. And we've got some number. Let's go and check it. Yes. Yeah, great. We just solved the first part of our tasks. Let's go and just solve the part 2. What we need to do here? Good, the computer seems to be working correctly. Okay, keep it nearby. During this mission you'll probably use it again. Real and code computers support many more features than your new one, but we'll let you know what they are as you need them. Okay. Encode programs are given as a list of integers. These values are used as the initial state for the computer's memory. Okay, data is a memory. When you run an encode program, make sure to start by initializing memory to the program's values. A position in memory is called an address. For example, the first value in memory is an address 0. Okay, it's clear. Opcode like 1, 2, or 99 mark the beginning of an instruction. Okay. The values used immediately after the opcode, if any, are called the instruction's parameters. Okay. We called it operands in our code. For example, in the instruction 1, 2, 3, 4, 1 is the opcode, 2, 3, 4 are parameters. The instruction 99 contains only an opcode and has no parameters. Okay, what we need to do? It's clear. The address of the current instruction is called an instruction pointer. It starts at 0. After an instruction finished, the instruction pointer increases by the number of the values in the instruction until you add more instructions to the computer. This is always 4. For the add and multiply instructions, the HAL instruction would increase the instruction pointer by 1, but it halts the program instead. Okay. With terminology out of the way, they are ready to proceed. To complete the gravity assist, you need to determine what pair of inputs produces the output. Okay. The input should still be provided to the program by replacing the values at addresses 1 and 2, just like before. In this program, the value placed in address 1 is called the noun, and the value placed in address 2 is called verb. Each of the two input values will be between 0 and 99 inclusive. Okay, once the program has halted, its output is available in address 1. Also, just like before, each time you try a pair of input, make sure you first reset the computer's memory to the values in the program, your puzzle input. In other words, don't reuse memory from a previous attempt. Find the input noun and verb that code the program to produce the output. What is for example, I understood it. Okay. Input hasn't changed. We need to copy that number for our future task. Extended data mgs, we just use it like before. Index mgs, import data from simple data mgs. Okay, and target is that number. Okay, what we need to do? We need change our values in the first and the second address, and start calculation till the end, and then we just get the value from the address 0 and compare with the target. If it equals, we just return now the pair from the first address and the second address. That's all. I think it's easier to use some brute force for it. We just reuse our code. Yes, great. And I think we need to recompose our functions, but the main idea is clear. We need get operands from the previous task. We need solve function, but it would be differs from the previous, and we just call it check, and here we would use another okay, let it be const memory data. Great. For each check we need memory, update memory, and we need to know what noun, verb. We need to update in our memory, and here also we use memory. Everywhere we use memory. Yes, wow, memory, great. But we need to noun. Address 1 is called noun, 2 verb. Okay. Here we need noun. Here we need verb. And we just iterate like before, but we need to return memory 0 and we need return something like that. Yes. And we don't use function check yet. In solve we would do something like that. We need 2 cycles, noun from 0, noun to less than 99, noun plus plus, and verb, yes. And we just need run check with noun and verb. And that's all, and it returns target const current result I think result and answer, yes. And if our current result equals target, we just console log answer, yes, something like that. And if it equals, we just need break outer break outer. I think that's our solution. Let's check it out what we are going here. We just memory let memory, okay. We import data from our file. We store it at memory variable. We know our target value, what we need to get from our operations. We need helper function to get some data from current position. We need a function check, which I think it's not okay. Compute, let's call compute, because check, it checks nothing here. Compute, we need two numbers, yes, we iterate for it and get some value from target position and value which result for us. And we've got four cycles. We make some computations and return result. Let's start the program and check it out. extended. What's going on? Nothing helps, yes. Some more loader is an experimental. Okay, it's okay for us. Data, compute, noun verb. Noun verb. Yes, it's okay. Let's result don't change. I see, didn't change. I see, we forgot to change our variable usage. Yes, that's it. That's all we need to do. Yeah. And that's our target value. Yes? Yeah, great. Thank you for watching. Subscribe for my channel. Add to the Telegram chat and read some and write some messages. Talk about my solutions and your solutions, and be the great programmers. Thank you for watching. Goodbye.